according to Feynman, anytime a particle, a photon, or even a macroscopic object moves from point 1 to point 2, it has some chance to take any path. And as preposterous as it might sound, he found that we need to include all these paths in our calculation, where each path is weighted the same. So why then do we not see all those crazy paths? Well, that's because we still need to add up their amplitudes. For simplicity, imagine we only have 3 paths. Then here's what we're going to do. First, let's take this one. When the particle wave starts following it, we start a stopwatch. It goes around and around very fast, and when it gets to the end point, we hit stop. We'll do the same for the other 2 paths. And then we add up the arrows, square the result, and that is then proportional to the probability the particle took those paths to get there. In this case, the arrow and square are pretty small, so the probability of the particle going from 1 to 2 using these paths is small. Compare that with these 3 paths, for example. Well, now the arrow is much larger. And this is important. The larger the resulting arrow, the higher the probability of that event happening. Now, in these examples, the stopwatch is not actually measuring time. Instead, it measures something called the phase. Just as in the double slit experiment, when a wave takes a different path from point 1 to 2, it will end up there with a different phase. And this phase is what determines the amplitude of the wave at that point.